Welcome to qiphyedu. Today we'll be looking at computer science, A2 level, paper 32, May, June 2023. Alright, let's start. Okay, so for the first question, it says numbers are stored in the computer using floating point representation with 10 bits for the mantissa, 6 bits for the exponent, 2's complement form for both the mantissa and exponent. And now we need to write the normalized floating point representation of the following binary number using the system. Okay, so you can see here, we have this number, 0101010111. So this one is a total of 10 bits. So now we just need to directly copy and paste this into our mantissa here. Okay, so that will be 0101010111. But then you realize that the dot is at this position. So we need to start from the leftmost dot here, which is between the first bit and the second bit. Okay, and then we use arrows to jump all the way to this position. So that'll be 1, 2, 3, 4, 5, 6. So that will be 6, and in 2-bit form that will be 110. So this will be 000110. Right? Okay, so to prove this to you, the exponent form, like what I mentioned just now, is 6. Here is 2 power of 0, then it's 2 power 1 and 2 power of 2. So 2 power 2 is 4, 2 power 1 is 2, so you plus that together, you get 6. Alright? Okay, B, describe the reason why the normalized form of the following binary number cannot be represented accurately using the system. Just now we saw that this number here is it fills in the gaps completely in the mantissa boxes here. But this one, let's take a look at how many characters there are. This one is how many digits there are, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's only 10 spaces here. This one is 13. So, or I should say there's only 10 bits, but then this one is 13 bits. So here we need to write the mantissa of this number. Need to be 13 bits, but it can only store 10 bits. The rightmost 3 bits would be truncated, or basically removed in layman terms. So it will be truncated, which results in inaccuracy. Right, so this is how you get 3 marks. Actually, there's already 4 marks. So the first mark will be this one, 13 bits. 2 marks will be this one, store 10 bits. Then the third bit would be this thing here, truncated, and then inaccuracy, 4 marks. Alright. Okay, question 2a. Describe how records are organized and accessed in a sequential file, so it's in a sequence. Okay, so first of all, we can just say that records are stored in a particular order. Which is based on the value in a key field. Okay, like that you get 2 marks, and then now we need to move on with a few more. Records are accessed one by one until the record is found or key field value exceeded. Alright, with that you get 4 marks. 4 marks will be records are stored in particular order, 1 mark. Based on the value in the key field, 2 marks. Access one by one until record is found exceeded, this one gives you another mark, so total 4 marks altogether. And B says the hashing algorithm is used to calculate storage locations for records and random access files. And then the function modulus gives the remainder after integer division. For example, 3003 modulus 5 equals to 3. So now we need to complete the table to show remaining hash values. So we just take 5, just take 1029 divided by 5, we get 205, so the hash value is 4. And then we take 7630 divided by 5, we'll get 1326. So this one is 0. Alright. Okay. Question 3, several syntax diagrams are shown. And A, state whether each variable is valid or invalid and give a reason for your choice in each case. So the variable here will be multiple letters. It could be one or multiple letters. It could be one digit or there's no digit at all. Here you realize that the digit comes before the letter, so this one is invalid. So just put invalid. And then before we access any further, let's rewrite anything further. We look at SW and see whether or not it's included in the letters. And they are. 9 is also included, so you just have to say the digit comes before the letters, which should be the other way around. Okay. Second one, UWY. So UWY, yes, it's possible. So just put valid. Begins with a letter, followed by 2 more letters. Okay. And B, word contains 1 or more letters. Complete the Backus now form for word and use this to complete the BNF for variable. Okay, so word, it could contain 1 or more letters, so we just have to put something like this. Letter contains 1 or more letters, so it's letter or word letter, so this will be infinite until whether you decide to stop or not. Then variable would be word. It could be word, and then it could be word, or you could jump to directly without the digit, or it could be word and 1 digit. Alright, so 2 options. So for word, the 2 options will be one letter only, or it can be infinite amount number of letters. Variable would be 1 word. Well, I mean, like, it goes to the word and then it would be multiple letters, or it could be word and digit. Alright. C, vehicle registrations must begin with 2 letters and be followed by 1, 2, or 3 digits. And valid letters and digits are shown in the syntax diagrams on page 4. State an example of a valid vehicle registration, so you can just put must begin with 2 letters, right? So you can just simply put letters like, let's say C, S, for example, and then followed by 1, 2, or 3 digits, so we can just put 5, for example. Okay, so this will work as well. If you want to put 2 or 3 digits, it's also okay. It depends on you. Now you draw a syntax diagram for vehicle registration. Okay, so vehicle registration. Okay, so first of all, 1 letter. I think I'm just gonna put small letter here. Right, then 2 letters, so we have to put 2 of these, and then 1 digit. And after the 1 digit, you can decide whether you want to jump. So you can see I'm running out of space, so I'm just going to move this to the left. Okay, 2nd digit. Okay, then the 3rd digit. Done. Then from after the 1st digit, you can just jump directly to the end, like so. Or after the 2nd digit, you could also jump to the end like this. There we go. This is the syntax diagram. Okay, 4. Draw 1 line from each object-oriented programming term to its most appropriate description. Okay, so encapsulation. Encapsulation would be the process of putting data and methods together as a single unit. Okay, getter is basically used to return the value of property. Polymorphism is basically to allow methods to be redefined for derived classes, and then setters would be to update the value of a property. Right, so like that. And 5a, encryption is used to scramble data to make it meaningless if intercepted, and describe the purpose of quantum cryptography. Basically to protect security. Sorry, to protect security of data. Yep. Data using fiber optic cables. And using laws of physics, or you can say using properties of quantum. Not only that, it can be used to detect eavesdropping. Alright, so that's how you get 3 marks. Protect security using fiber optic cables, properties of quantum, detect eavesdropping, 3 marks. Alright. B, explain the differences between symmetric and asymmetric cryptography when encrypting and decrypting data. So for symmetric cryptography, it only uses a single key, whereas asymmetric cryptography uses two. For symmetric cryptography, the symmetric key is shared. But for asymmetric cryptography, only the public key is shared. Alright. The risk of compromise is higher with symmetric encryption. Whereas for asymmetric encryption, it is more secure. Alright, so 3 marks would be from here to here, then second mark, then the third mark. Right. If you want to add one more, you can say that length of keys in symmetric encryption is shorter than those for asymmetric. Right, if you want to. And then for question 6a, we need to write pseudocode statements to declare the composite data type. T appointments to hold data about patients for dental clinic. It will include for each patient name, first name and last name, date of birth, telephone number, date of last appointment, next appointment, all treatments are complete or not. So here we just need to declare a new type. So the type here would be T appointments. And then declare name, string. You can declare date of birth. As the date. Declare telephone. As string. Then declare date of last appointment. I'm just going to shorten it to appoint. This one is date. Then date of next appointment. And then all treatments are complete or not. This one will just say treatment status, treatment completed. This one is Boolean. Okay, and then end type. Alright, B, the pseudocode algorithm reads dental records stored in a random file using the user-defined data type T appointments and prints the contents of the file one record at a time. Complete this file handling pseudocode. So, okay. Declare dental record array 1 to 50 of T appointments. Declare dental file string. Declare count integer dental file.dat. Output the file dental file contains these records. Open file dental file. Because dental file is dental file.dat. This one would be, it says record store in random file, so this one is for random. And then the count here is integer, so just set it to 1. Then repeat seek dental file count, and then we'll get the record. And then it will be dental record. And this one will be the count. Okay. And then count plus 1 until EOF, and then we close the file. Okay, that's for this pseudocode. And 7a, state 2 examples where it will be appropriate to use packet switching. We just say it's for use on data networks such as sending large files over the internet. It is also used for transmissions that do not require the entire bandwidth. For example, sending email, right? So 3 marks in total. So first mark will be this one, second mark will be transmission that do not require entire bandwidth, and the third one will be the example. Okay. B, give 4 differences between circuit switching and packet switching. So we can directly say that first of all, we can say that circuit switching uses dedicated channel. Circuit switching uses dedicated channel. Uses dedicated channel to make communication. Whereas packet switching forms data into packets. To transmit over network. The second one, you can say that in circuit switching, all data uses the same path. But for packet switching, the packets uses multiple routes. For circuit switching, information received is in the same order as the original. But for packet switching, the packets may not arrive in order. Okay, then you can say that for circuit switching, uses the entire bandwidth, the same as the top, uses the entire bandwidth, whereas packet switching does not. Okay, so that will give you 4 marks. 8A, describe the use of pipelining in reduced instruction set computers, basically to use to process something simultaneously. So allow several instructions to be processed simultaneously. Which increases CPU instruction throughput. And then each instruction stage is completed during 1 clock cycle. Okay, this will give you your 3 marks already, but let's add one more. No 2 instruction can execute their same stage of instruction. Let's say, for example, you have 6 stages for different instructions. Let's say you completed 1.1, then you move on to 1.2. Then for instruction number 2, it will go with stage 1, so like 1.2, then 2.1, something like this. But it cannot be 1.2 and then 2.2. Can execute the same stage of instruction. Alright, so this is how you get your 4 marks. This one is only a 2 mark question, but we already have 4 marks. Like this, and then this, then this, then this. Alright. Then the processing of instruction is divided into 5 stages. Instruction fetch, decode, operate, fetch, instruction execute, and write back result. And each stage is carried out using a different register when pipelining is used. And then complete a table to show how a program consisting of 6 instructions will be completed using pipelining. Right, so then here just put 1.1, 1.2, sorry, 1.1, 2.1, and then 3.1, 4.1, 5.1, 6.1, right? So 5 stages. Okay, and then this one is 1.2, 2.2, 3.2, 4.2, 5.2, 6.2. Right, then this one is 1.3, then 1.4, this one 1.5, this one is 2.3, 3.3, 4.3, 5.3, and 6.3. This one is all the way until 6.4. Okay. There you go. This is one way of doing this. There's also another way, but this one is the much better way because it shows completely how it completes everything. Right. Then Question number 9, this truth table represents a logic circuit, and then we need to write the Boolean logic expression that corresponds to a given truth table as the sum of products. So this one, you can see here that the only one with the output would be this 4, and then this. So we can just ignore all the things that has a z equals to 0. So basically this entire thing, we can just ignore it. So we only have 6 things that we need to put in. So this one that we need to put in the logic expression. So this one, the first one will be not A, not B, not C, not D. So it'll be like this. Okay, and plus. This one is not A, not B, not C, and D. Okay, then the third one would be not A, not B, and then C and not D. Okay, and fourth one would be not A, not B, and C, D. Then last two, the second one will be not A, B, C, and not D. And finally, not A, then B, C, D. Okay, done. Then B, complete the Karnaugh map for the given truth table. So not A, not B, not C, not D would be this, so we just put 1 here. Then not A, not B, not C, and D would be this one, because D is 1. Then not A, not B, and C and D, so that would be 0, 0, 1, 0. So this would be 0, 0, 1, 0 would be this one. And then not A, not B, C, D, so that would be 0, 0, 1, 1. So this one. And then not A, then B, C, D, so 0, 1, 1, 0. So 0, 1, 1, 0 would be this one. And then last one is not A, B, C, D, so 0, 1, 1, 1. 0, 1, 1 is this one. And then we get 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Now we need to draw loops around appropriate groups in the K-map to produce an optimal sum of products. So you can see here, we have an entire group of 0, 0. So this would be 1 for sum of products here. And then the second one would be this one, where all of them have basically this one will be either 0, 0, 1, 1, 0, 0, 1, 0, 0, 1, 1, 1, and 0, 1, 1, 0. Right, so write the Boolean logic expression as a simplified sum product. This one is not A, not B. The second one here would be, both of them would have not A, but then the C would be 1, so not A and C, that's the answer. And then we need to use Boolean algebra to give you answer in its simplest form. This one will be not A bracket not B plus C, right? Is the answer for that. And then state one category of machine learning. So this one of the examples will be supervised learning. The other examples would be unsupervised learning, reinforced learning, and also deep learning, right? And B, calculate the path that takes the shortest time to travel from the begin node to the end node using the A-star algorithm and show you working in the table provided. Okay, so we begin, and destination node is A. This will give us start node of 5, heuristic 8, 13. Then we also start from begin again for B, and then for C, and for D for until G, until begin until D, because that's where it's all connected. So A, B, C, D. So here we just do this 3 times first. B, C, D. Okay, so for B, that would be G would be 6, and then our H would be 7. So it's 13. And then for C, it will be 5 and 7, so that will be 12. And for D is 4 and 11. So that'll be 15. Okay, then now we need to calculate from C to G, and then we know that because here directly we can see that for C to G, the heuristic is 5 and the cost from start node is 2. So just put C and G. C and G would be 2 and 5. So so it gives us 7. Okay, so you can see here that the reason why we're directly jumping from C to G is because if you look at the begin node here, the shortest one would be from begin to C. So that's why we just jump from C to G. Then from G, we need to calculate from G to F or G to N. So now we just calculate G to F. G to F would be cost from start node before, and the heuristic value would be 1. So that will give us 5. Sorry, it's not from G to F would be, we need to add up together. So from G to F would be okay, from C to G, right? From C to G is not 2 and 5. Instead, it should be, it has to calculate, you have to calculate the cost from the start node as well, so from the begin node. So C to G, that will be 5 plus 2, so we get 7. And then heuristic here would be only 5, so it would be 12. And then from G to F, you need to calculate the cost from the heuristic node, from the start node, sorry. So from the start node here would be 5 plus 2 plus 4, so 5 plus 2 plus 4 will get 11. And then the heuristic would be 5, so you get 6, sorry, you get 0. G to F, you get 1, because the heuristic for F is 1, so you get 12. And then from G to N, you need to calculate from the start node as well, so it will be 5 plus 2 plus 7. So you get 14, and then heuristic would be nothing, so just put 0, so this one get 14. And then we can calculate from F to N. So from F to N, you need to calculate the cost from the start node, so 5 plus 2 plus 4, you get 11, and then plus 1, so you get 12. And then the heuristic would be 0, so you get 12. So the final path would be begin to C, then to C, and then to G, then G to F, then to N. So we calculate based on the total of the cost from start node and also the heuristic in order to get to our final destination in the shortest way possible. Right, 11a, the pseudocode shown represents a Q abstract data type with procedures for initialization and to add new items, and it is incomplete. You need to study the pseudocode and insert the identifiers to complete this table. Alright, so here we need to identify the identifiers. Here you can see that so you can just take directly from these 4. So here we can just declare Q of array, array of strings, so this one is Q. Alright, and then integer points to the last item here. Last item would be our rear pointer. And then indicates number of items in the queue, that would be our length. And then last one would be our front pointer. Then we need to complete the given pseudocode. Alright, so front pointer equals to -1, and then our rear pointer is also -1. And our length would be 0. And the procedure, then NQ. So if our length is less than max length, in this case it is, then our rear pointer will then equal to rear pointer plus 1. Okay, and if rear pointer is more than max length minus 1, then rear pointer is 0, and then new item, we're adding a new item, so just put Q, and then this is our rear pointer. This one is our new item. Okay, like that. So we're adding a new item, so based on the If the fact that our length is less than our max length, then rear pointer will be rear pointer plus 1. If not, then rear pointer will be 0. And then the queue will, then the new item adding to the queue would be, let's say if it's rear pointer more than max length minus 1, then it will be towards 0. So our q0 would be where the new item will be placed. If not, it will follow the top one if, let's say, the length is less than the maximum length. Right? So B, explain the reasons why a queue ADT works better than a stack ADT in organizing print jobs, because print jobs are supposed to be executed in order. In order that they arrive. Okay, first mark. And then second mark is this is because printer queue is a queue. The first job would be the first one printed. So we can just give an example of a condition. If a stack is used instead, the first job would be the last one printed. Alright. Printed as it is on the bottom. Of the stack. Alright, so that's how you get 3 marks. And then this is the end of this paper. I hope you guys find this video helpful. Do share this video out to other people who may need help with computer science A2 level. As always, I hope to see you guys again in the next video. Till then, this is qiphyedu. Goodbye.